Hello students, welcome to the session 2, that is experiment 2 of the digital design part A. So in this session we will be learning about the buffer. So as we know that it is buffer is a device, electronic device, which is uh, popularly used in the electronic circuit design. Okay, to write the Verilog code for a buffer circuit and its test bench for the verification, observe the waveform and synthesize the code. So here also the tools required is Xilinx ISC, and this is the symbol and the input output table for the buffer. So you can see that we don't have any bubble here. For inverter we will be having a bubble, but for this we don't have any bubble. So just it is a triangular symbol where input, what we are giving the input will get at the same at the output. Okay, so it can name it as a boosting device also. Okay, where it will not delay or degrade the values. What is there in the input, the same thing will be carried out to the output. That is the function of buffer. So it is a sum of the theory. A special logic gate called a buffer is manufactured to perform the same function as the two inverters. The symbol is simply a triangle with no inverting bubble on the output terminal. Buffer gates are merely serve the purpose of signal amplification, taking a weak signal source that is not capable of sourcing or sinking much current and boosting the current capacity of the signal. So has to be able to drive a load. This is the program what we have written for the Verilog program for the buffer module. Module name is buffer. The input parameter, input, output, assign. This is my concurrent statement. Just I am assigning the input to the output. End of the module. So in test bench we are giving some multiple input values. Okay. Next, this is the waveform what we have observed. That is, what is there in the input, the same thing will be taken at the output. So these are the some of the multiple choice questions. Which type of the simulation mode is used to check the timing performance of a design? It is gate level. Which among the following is an output generated by the synthesis process? Gate level netlist. Let's generate a gate level netlist. Next, register transfer level description specifies all of the registers in the design and dash logic between the combination. In testability, which terminology is used to represent or indicate the formal evidence of the correctness? So the verification. The output of a buffer is complemented or non-complemented. So the answer is, for this it is, answer is non-complemented, that is B. Okay. So if any wrong is there, we need to see that what type of question it is as. The output of the buffer is a non-complemented. Okay. Just, next we will uh, try to see how to execute the program in a Xilinx. The same thing, we'll be having a Xilinx tool in the desktop. Double click on that. Okay, here it will give design summary. That is what type of device it is, selected, module name. Once we select the project, we can see the design summary also. Here, go previously open files are there, just close this file, close project. Next, file, new project. So here we are writing a program for buffer. Just write it as a buffer. So you can take a date for a to verify that you can take that particular date also, or else the name should be given differently, should not be the same what you are given previously. Next, here we will be having some of the property, product category, family, device, package, synthesize and simulated tool, and what type of language we are using. So next, finish. So after that project name given, next go to project, new source. Here we are selecting the Verilog module and we are writing the program for buffer. It will give the module name, Verilog module name. Next, Here once again we have two inputs, A comma B. You need to select it as an output because A is input and B is output. Next, finish. So here we'll get a module name with the input and output parameter. So here also we have a single concurrent statement, assign B is equal to A. Okay, it is a concurrent statement, that is input is assigned to output. After that, just every program we did, after editing every program we need to save this, Control S. Next, check syntax. Do the check syntax, synthesize XST, check syntax. So here also once we have written the Verilog program, after that only we can see the RTL schematic. It has not selected buffer symbol, so just it has given the block. Okay, next, let's close this. Design summary also you can close. Next, new source, we need to write a test bench program for this. Buffer 9, buffer 8 shift underscore db. Okay, test bench program. Next, finish. So we have created the test bench program. Just you need to give the input values. So some delay you can give a multiple input values. 0 we have given already. Now next we'll change it to 1 1 0 1 0 1. Okay. After this, again once again save, Control S, select the simulation, select this, and ISC simulator, inbuilt ISC simulator will be there. So simulate behavior model. So this is the waveform what we get for the buffer run for some maximum delay. We'll give it 10 nanoseconds. So just zoom full, so you can see, observe that what we are giving in the input, the same thing will get the output. Low, low, high, high. Okay, so this is how we can verify our main program with the test bench program by comparing the values in a waveform. Thank you, students. Once again, we'll see in the next program with the next module in the next session. Thank you.